Okay, so let's see. Let's solve another problem, which is a little bit even more interesting. I don't want to say complicated, but little bit more interesting. Okay, so say maybe Dr. Kaku again. Dr. Kaku put his put his bike, okay, just inside his car, and drive back home, right? Yes, yeah, yes. Dr. Kaku put his bike inside his car and drives back home. And the position function is, well, the acceleration. Let's give the acceleration. Let's make the problem a little bit more interesting. All right, SQ, and this is T. This is acceleration. So what are we going to find? We're going to find velocity, and so let's find velocity, and what else we can find? Displacement, maybe. Displacement after 2 seconds. All right. So how are we gonna solve this problem? Okay. So okay. So that's we asked to find the velocity and the displacement, right? But the velocity is not given, the acceleration is given, so we have to go to backward. All right. So remember, we in our first math tutorial, in our first physics tutorial, we did some math review where we discussed some integration. So this comes handy. So we know that acceleration is dv over dt, and we do the cross multiplication, we get dv equal to a dt. Now if we take the integration of both sides, right, from 0 to b and from 0 to t, we simply get b equal to 0 to t. A is this guy, 7 meter second cube, and t dt. Right? If this looks complicated, then I ask you to watch the first the first video tutorial where we have discussed some differential and integral calculus. So we are basically doing the integral calculus, integration. So B is, now we're gonna do, what are you gonna do? You're gonna take the integral of this one, which is okay, so let's put the constant outside. 7 meter per second squared, and 0 to t dt, right? So now 7 meter second squared, what is t? Remember, we did for xn, which is dx, which is x n plus 1 over n plus 1 plus c. But this is bounded, there is a limit, so we're not going to put c, right? So, oh, this is SQ. You cannot mess with your unit. So t squared over 2, 0 to t, okay? All right, so now we get 1/2, and then 7 meter second squared t squared. Okay, so this is our this is our acceleration. Okay, so looks ugly, but you know, but you know, it is what it is. Okay, so let's find the displacement. Okay, so this is step 1 of finding the displacement. Step 2 would be, here we have the velocity. This is our velocity. We have to find the position. This is our velocity. Okay, so we have to find position. So what is position? Velocity is dx over dt. Alright. So cross multiplication, the way we did here. We did the cross multiplication. Alright, so the same way. So dx is b dt. Alright. So let's integral both sides. 0 to x and 0 to t. Okay, so x is well, 0 to t, b is, well, the time is given 2 seconds, so you're gonna write 2 here. So b is well, this crazy thing, 7 over 2 meter second cube, and then t squared, and then dt. Right. Okay, but we can do it. So let's put the constant outside. 7 over 2 meter second cube t squared dt. 0 to 2, let's not forget that, that's important. 7 over 2 meter second cube, and then what is the integration of that? Simple, t3 over 3, and then 0 to 2. Now finally we'll be able to find the displacement, right? So 7 over 2 meter per second cube, and then if you put 2, then it's 8, and then second cube, and then over 3. Okay, and then minus, if you put 0 here, it's going to become 0, so minus 0. How? Okay, that's, I mean, you know, 7 over 2 meter second cube over 0 cube over 3. So 0 cube makes everything 0. All right, so that's how we actually got 0 over there. Second cancel. So x is second cube cancel. So x is actually 56 over 6 meter. So 56 divided by 6 is about 10 meter. So the displacement was about 10 meter. All right. So that was the displacement of Dr. Kaku, who is acceleration was that. So the displacement, that means after 2 seconds, he moved almost 10 meter. Right? So he was moving pretty fast, because not 2 meter per hour, 2 meter per, excuse me, I think all those particles of chalk goes into my nose, and that causes the sneezing. I call it particles, I didn't call it dust. I don't know why. Okay, so let's make the next question even more, I guess, more difficult or more interesting. Well, let's see. Okay, so say now Dr. Kaku now moves fast or slow, I don't know. say x equal to at square plus b. That's this position function where a is I guess 2.10 meter per second square, and b is his y-intercept. B is his y-intercept, so same color. B is his y-intercept, so B may be 2.80 meters, right? Oh no, what we got 10 meter last time, so let's B be 10 meter, right? Remember last time in how long? In 7, his acceleration was 7 meter per second cube, and it took him 2 seconds to go 10 meters. So now his initial position is 10 meters. What are we trying to find out? Number 1, we're trying to find out velocity, I guess. I mean, velocity. Well, I don't know. What can we find out? Maybe displacement. Displacement. All right. Number two, maybe velocity, average velocity. Number 3, instantaneous velocity, I guess. Instantaneous velocity. And number 4, I guess, is instantaneous acceleration. Instantaneous acceleration. Okay, so the problem is becoming more and more interesting. So there is no reason to pay less attention. Okay, so let's see the displacement from, I guess, from t is 3 seconds to t is 5 seconds. Okay, and the instantaneous velocity is t is 5 seconds. So instantaneous velocity at t is 5 seconds. Okay, so let's see. Displacement is pretty straightforward. All you need to do, plug it in the time. So x is a t squared plus b. So a is 2 point, let's make 2.10 is 3. So 3, and then the first one is 3 second squared plus b is 10 meters, which gives us 27. Okay, 27. Acceleration is 3 meter per second square, and then 3 second square plus 10 meters. Alright, so 3 meter plus second square, 9 second square plus 10 meters. So second cancel, 27 plus 10, 27 meter plus 10 meters, so 37 meters. Okay, so x1 is 37 meters. So let's see x2. X2 is, we have to plug in 5 now instead of 3. So x2 is at squared plus b, all right, x is x2. So a is 3 meter per second square, t is 5 second square, plus b is 10 meters. Okay, so now 3 meter second square, 25 second square plus 10 meter. All right, so second square cancel. So now what do we get? 75 meter plus 10 meter which is 85 meters. So 85, x2 is 85 meters. So what would it be our displacement? Displacement is simply x2 minus x1, which is 85 minus 37, which is 85 minus 37, which gives us 48. So displacement is 48 meters. And that's the displacement. What is velocity? Velocity is kind of, we use the same information. So displacement over change of time, 5 seconds minus 3 seconds, this is 48 meters equal 2 meters, which is 24 meters per 2 seconds, 25 meters per second, right? So the velocity, average velocity was 24 meters per second and displacement was 48 meters. We're going to do the instantaneous velocity and instantaneous acceleration on next video.